So, welcome to the video lecture series on theory of computation. So, in today's lecture, we will be discussing about the second concept called as mathematical preliminary. So, the first part we have discussed about the mathematical preliminaries, and we will be discussing some more concepts which is related to mathematical preliminaries. And in a mathematical preliminary, you should know what is meant by prefix and suffix. So prefix, when you take up a string, the left-hand portion in a string is considered as prefix, and the right side of the string is called as suffix here. So you can divide the string into two portions as left and right. Okay, but mathematically, how will you define this? So when we take up a string w equal to uv, where u actually stands on the left side and v on the right side, so we can say that u is actually the prefix and v is called as a suffix here. And u and v, obviously it's called as a substring of it. So in short, we will have an example for it. For instance, if we have w equal to 0, 0, 1, and if none of the symbol is included, so as per the mathematical definition, it is called as epsilon, and you just move from the left side prefix, since we want to evaluate the prefix here. So 0 is a prefix, whereas 0, 1 is another prefix, 0, 1, 1 is a prefix, and even you can include the whole string as a prefix here. And suffixes, as usual, if none of the symbols is included, epsilon is a suffix, whereas you take on the right side, 1 is suffix, 1, 1 is a suffix, so on and so forth. Okay, so I will just give you an example for this. So suppose I take a string called as w equal to AB AC. Okay, let us take this. Now I want to find the prefix of it. So the prefix is, as usual, that if none of the symbols is included here, then we can say epsilon is a prefix. And if since prefix you have to take from the left side, so A is a prefix, and then AB is a prefix, ABA is a prefix, and now ABAC, even the full string can be included as a prefix here. Now, what is meant by suffix? So suffix, so if none of the symbols is included, then we can say epsilon is a suffix. And since suffix you have to evaluate from the right side if you include C, so that is a suffix, then AC is a suffix, and BAC is a suffix, and then include the whole string. A, B, AC is also called as suffix here. Okay, so now this is mathematically defined. Now, what is meant by palindrome? So when you take up a string, then if you just reverse the string, if it matches with the original string, then that is called as a palindrome here. The best example for this is you take up a string called as u, and you know that u to the power of r is called as the reverse of the string. That means if u matches with ur, then we can say that this string is called as a palindrome. So how do you actually define it mathematically? I will tell you how to define this mathematically with a set of examples. Now, for instance, I have a string called as, let us take that S is called as a string, and I take the string as A, B, B, A. Okay, so now this is S is called as string. Suppose if I reverse the string, so S to the power of R is called as reverse. So what is meant by reverse? You have to just put the right side value on the left side. So A is on the right side. So A, then you have to put B, then again B, and you just start with A here. So what happens? So S equal to S to the power of R. So say this is both are equal. So it is called as a palindrome. Now I take up a string called as S equal to ABB. Now if I want to reverse that, S to the power of R. Now you start from the right side. So B, B and A. Okay. So now what does it mean? S is not equal to SR. So in this case both are not equivalent. Okay, so is not a palindrome. Okay, so if the string is actually equal to the reverse of the string, then we can say it is called as a palindrome here. We'll go to the next one. What is meant by associative? This is a set of properties which is concerned with mathematical preliminaries. So concatenation on a set epsilon to the set of 0, that is sigma of 0, then it is called as associative. What is associative? Then we can say that if u is taken as a string and v and w are taken as a string, and if you just concatenate it all together, finally all will become equal over here. Now I will just tell you with an example here. So how to do that? So how to prove that it is associative? Now see here, I say that u is equal to a, v is equal to b, and w is equal to c here. Okay, now I have taken three different strings here. Now what is the condition? So u, v, w should be equivalent to u, v, w. So first what I am doing, I am associating v and w. So what is v? V is actually b and c. Okay, and then what is u? U is actually a here. Now what I am doing, u and v, again I am associating. So what is u and v? A, b associated with w, w is actually c. Now if we concatenate together, finally I will be getting abc is equal to abc. So that's what the rule says. Okay, so if you say that u, v, w is equal to u, v, w. So this is called as the associativity rule here. Both are equivalent. Now sigma star, we can say that when you just cancel the left side and right side, you will get both are equal. And you can see here w, u equal to w equal to v. So on left side and right side you have two equivalent strings here. When you cancel it together, so finally u is equal to v. And if you say that u, w, so again now you have strings which is equal on the right side of the string here. So in left side and right side you have same string, which is now this is called as right associativity. So in right associativity, if we cancel that w, so again it will be equivalent to u equal to v. So this is one pattern, and the next property is actually if you have u, v, w. So in this sigma to the power of star, sigma to the power of star means a set of symbols in an alphabet. Over an alphabet is called a sigma star k. So I want to find the length of ub, the concatenated string, the length of ub is actually equivalent to the length of u and length of v. So how will you prove this? So to prove this, now I say that u is equal to, I write a, and v is equal to, I write a string called as bb. Now when I concatenate uv, so what will be the string? So uv, I am just concatenating it. uv is equal to, now it becomes aa, bb. So what they are trying to prove here? So if I find the length uv is equivalent to the length of u plus the length of v. So what is the length of uv? uv is equal to aa, bb. And what is u here? U is written as AA and V is written as BB. So now you can see here the length of AA, BB, you have four different symbols here. So the length is actually 4. Now AA you have the length called as 2 and BB you have the length called as 2. So you can say that 4 equal to 4. So hence the property is getting proved here. So now what is meant by a language here? So set of the alphabets, the set of symbols over an alphabet is called as language. So if you are just putting the symbols repeatedly of an alphabet, you will get a string here. Now what is meant by a language here? So the language, you can say that if I say empty string is also considered as a language here. Now I will just try to prove it. Now see here, I have a set of alphabets sigma equal to a comma b. So this is called as a set of alphabets here. When I use sigma star, that means you can just repeatedly use this a and b n number of times, or even you can use 0 number of times. So if you use 0 number of times, what does it mean? So if none of the symbols is used, you will get the answer called as epsilon. If a is alone used, you will get a, and if b is alone used, you will get b. If a is getting used 2 times, a. If b is getting used 2 times, b. And if a is used 1 time and b is used 1 time, you will get ab. If a is used 2 times and b is used 1 time, you will get ab. Okay, if b is used multiple times, 2 times, and a is used 1 time, so on and so forth. So this is called as the language. So this concept. Okay, so this all the strings which are generated here is called as the language here. Okay, suppose if I use sigma equal to 0 comma 1. So what is sigma star? So you can use epsilon none of the times. You can use 0, you can use 1, 0, 0, 1, 1, 1, 0, 0, 1, and 1, 0, 0, or 0, 0, 1, or even if we use triple zeros. So all these are called as languages here. So everything is called as language. Okay, so the language is actually denoted by a capital symbol called as L here. Okay, so that's what the language property says here. So you can say that this language, okay, this is called as language L. The language L is actually a subset of sigma star. So when I say that sigma star, the sigma star does not have any limitation here. It can extend to, it can go to any extent, it can repeat any n number of times. Okay, but the language is limited. So language is called as a subset of sigma star. Okay, so whether it is going to stop over here, no. Obviously you can include even b like this, a like this. Okay, maybe this can be continuing in any fashion. So language is actually, it is called as a subset of sigma star here. So that's what it says. Now I'll go to the next one, and this is what we have already defined. We have already said that when sigma is called as a b sigma star, you can see epsilon a comma b a. So these are the languages which are getting generated. Okay, so we can say that a b all this called as language. It's called as a finite language. But what is meant by a finite language? The set of the strings which is included in the language is limited. So when you take a bell here, you are having only 3 strings over here. A B, A, B. Is 3 strings are there. This is called as a finite language. But when a pattern is given, say for example, when L is equal to A to the power of n, B to the power of n, and whereas n is greater than or equal to 0. So this n can take any value which is equal to 0 or more than 0. Okay, that's not any limitation in this n. So when this n keeps on continuing like this, so this kind of language is called as infinite language. So there's not any limitation in generating the strings over here. Okay, this can generate any n number of strings here. So it's called as infinite language. Now we'll just discuss about the complement of L. Suppose I just try to find what is complement of L here. So if there is a language called as L, and the complement of L is actually whatever the language is which is not included in L is called as a complement of L. Say for example, now I will just try to discuss that. So concatenation, we can say that L1 belongs to L2 and U belongs to L1 and V belongs to L2. So this is, and L inverse is called as just a reverse of the string is called as the inverse of the string here. Okay, so what is meant by complement here? Say for example, I have an alphabet So for example, sigma is equal to 0, 1, and I just have a language called as L is equal to, so which includes this alphabetic symbol. Say for example, I have 0, 0 and 1, 1 and 1, 0. It's called as a language. Now my language is limited. So what is meant by complement of the language? I say that the complement of L is called as L dash. So L dash can be written as sigma star minus L. Okay, what is sigma star? Sigma star, I can include anything here. Sigma star except these three. Okay, L is given as 0, 0, 1, 1, 1, 0. So what is the complement L dash here? So I can write the complement of L dash as 0. I can include 1. I can include epsilon. And I can include 000 because 000 is not inside the language. Okay, anything which is not included in L is called as complement here. I can include 110 because 110 is not existing, but I cannot include 00 because 00 actually exists in this L here, so that is not considered to be a complement of it. But I can include 111, so this is actually called as complement. So anything which is not inside this L is called as the complement of L. But whenever you take up this generate a string, all the strings has to be strictly adhered to the symbols over here. So I have in alphabets, I have only 2 symbols here. Only these 2 symbols you have to use to generate a string over here. And this concatenation, you know that when I just merge 2 languages L1 and L2, and we can say that U belongs to L1 and V belongs to L2. So these are actually the traditional mathematical terms. And now, what is meant by union of L1 and L2? So if I just merge 2 languages, we can say that the resultant language will be either belonging to L1 or belonging to L2. And now when I use intersection means the resultant language actually belongs to both L1 and L2. So how will you prove this? Now I say that just listen carefully. Now I have the language called as L1. So I have AA and I have BB. Now L2 I have AB and I have BA. So these are the 2 languages now. Okay, now if I try to merge L1 union L2, L1 union L2, so all these things has to be put in the set here. So what is that? AA, BB and AB, BA. BA will be the answer. Okay, now if I take AA, so AA actually, so this is called as a resultant set. Okay, AA belongs to, now it belongs to L1. When I take BB, BB actually belongs to L1. When I take AB actually belongs to L2. And BA belongs to L2. Okay, that's what. So whatever the members inside the union of the set here, okay, it either belongs to L1 or L2. So that's the meaning of this. Okay, now I'll go to the intersection part. Now I take up intersection. So I have L1 equal to, I say AA, BC, and L2 I take AA, CD. Now if you take up these 2 elements, now L1 intersection L2. So what will be the result? So anything which is common to both the languages will be the result here. So what is common to both the languages? It is called as AA and AA. So both are common. AA is common to both L1 and L2. So AA. Now what does it mean? AA belongs to L1 and AA belongs to L2 also. So the resultant set or the resultant language actually belongs to both the languages called as L1 and L2. So that's the rule of intersection formula. Okay, so that's all I want to say. Thank you and bye bye. All the best. Okay. So if you need any clarification